Hi folks, this is Applied Calc 2, Checkpoint Quiz 2. Number 1, we're given a marginal cost function in dollars for producing X items to be this formula. Part A, find and interpret MC of 20. So, to find MC of 20, we replace the X with the 20. So 0.4 times 20 plus 10. 20 times 0.4 is 8, 8 plus 10 is 18. So the find part, the MC of 20 is 18. And what does that mean? Well, we think back to Calc 1. The marginal cost is an approximation. How much the cost will change if I increase production from what I'm currently at to one more. So one way we could write this is if production were increased from 20 to 21 units or items, the cost would increase approximately $18. So there would be an approximate increase in cost of $18. So that's a nice little flashback to Applied Calc 1. Part B, an honest-to-goodness Applied Calc 2 question now. Find and interpret the definite integral from 0 to 20, MC of x dx. So, I integrate the marginal cost function, and we're going to apply the fundamental theorem of calculus to find this integral. The fundamental theorem of calculus, the first thing we have to do is find an antiderivative. So, as we did in class, x equals 0, x equals 20. So the antiderivative of 0.4x, 0.4x squared over 2. The antiderivative of 10, 10x. I toss in the upper limit of integration. I subtract off what I get when I plug in the lower limit of integration. So plugging in the 20, I get 0.4 times 20 squared over 2 plus 10 times 20 minus 0.4 times 0 squared over 2 plus 10 times 0. Well, this adds up to a whole bunch of nothing. So what do I get over here? Well, 20 squared is 400. 400 over 2 is 200. 200 times 0.4 is 80. 10 times 20 is 200. So my answer is 280. So the value of the definite integral is 280. That's the find part. What's the interpret part? Well, remember, we can interpret a definite integral as a total change. MC of x is a rate function. That's the derivative of the cost. So we can interpret this as a total change in cost. So the total change in cost is $280. But what else? Well, look at the x values. They run from 0 to 20. So that's talking about over the production of the first 20 items. So we could say that over the course of producing the first 20 items, the total increase in cost is $280. All right. Part C. If the fixed costs are known to be $2,000, recover the cost function C of x. Alright, so MC of x is the derivative of the cost function. That's 0.4x plus 10. So if I want to get back the cost function C of x, I can take the antiderivative of MC of x dx, the antiderivative of C prime of x dx, the antiderivative of 0.4x plus 10 dx. And we already did this up above. We found one antiderivative, 0.4x squared over 2 plus 10x. To get all the possible antiderivatives, we just tack on a c. We can simplify this a little bit. 0.2x squared plus 10x plus c. The question is, which one of these is the cost function we want? Well, we go back to this. Fixed costs are known to be $2,000. Fixed costs are the cost when x is 0. So if you remember back to Applied Calc 1, all the stuff with the x in it is the variable cost. So this is then the fixed cost. So the fixed costs are $2,000. So we get c of x is 0.2x squared plus 10x plus 2,000. And that's our final cost function. Part D. Compute c of 20 and compare this answer to part B. So if I toss in 20, c of 20, 0.2 times 20 squared plus 10 times 20 plus 2,000. 20 squared is 400. 400 times 0.2 is 80. Plus 200 plus 2,000. That's 280 plus 2,000 is 2280. Now the answer to part B was just 280. Are these answers the same? No. They're off by $2,000. Should they be the same? Well, they shouldn't. Remember the integral from 0 to 20, mc of x dx, this is the change in cost. So if you notice, the cost to make 20 units is $2,280. But the fixed costs are $2,000. So what's the change in going from 2,000 to 280? That's right. This right here, part B, 280. So the change in cost is 280. So that's it for number 1.